In number 11, we're wanting to write the definite integral for what we are seeing. So what we want to think of is when we see the summation notation, that's like the S for the integral, and the delta x is like the dx. And the change in x is really the width of each rectangle, because we're basically finding the area between the curve and the x-axis here. And we're approximating it using rectangles. But if we create more and more rectangles, so their width or their delta x becomes smaller and smaller, in other words, that delta x heads towards 0, we're going to get closer and closer to the true area under the curve, or area between curve and x-axis. And the function that we're working with here is, think of that as x squared plus 4, so it's the square root of x squared plus 4. And we are integrating over the interval 0 to 3, so I put a 0 as my lower limit on my integral and a 3 as my upper limit on my integral. So when you see an integral symbol, you can think of sum up rectangles starting at 0 going to 3 of this function, and then remember that the height of the rectangle is the value of the function at that point, and then the width of the rectangle is the change in the x values. And if we multiply those together, we get the area. So we're summing up areas. So this is our final notation here.